Hi everyone, at Digital Colmer here, and today, courtesy of Wally the whiteboard, we are talking about reinforcement learning. That's AI that learns by doing. So welcome AI gamers. Today we're diving into reinforcement learning, the video game of AI. It's all about learning through trial and error, just like mastering a brand new computer game. So let's power up and explore. Okay, here we are. So, believe it or not, this is a maze with a start and an end. And we want to navigate this maze to reach our treasure. So, imagine an AI agent down here as a player in a video game maze. The goal? To reach the treasure chest using the fewest moves. And that's reinforcement learning in action. But how does it work? And we need to cover some terminology. Let's look over here. Here are the key elements in our reinforcement learning game. We have state. This is where our agent is in the maze. In other words, where the person is within that maze. Action. This is the moves that our agent, our person, can make. So you're starting to understand now that person, we call that an agent. Reward. Yes, points for good moves and penalties for really bad moves like dead ends in the maze. And then finally, environment. Well, that's the maze itself. It's the twists and turns that make up the entire game. Wonderful. Let's move through and see how this works in action. So the game loop might look like this. The agent observes its current state. It then takes an action, maybe to go forward, to go left, or go right. And then depending on how successful that action is, we might give it a reward. So if it makes good progress, we reward it. If it ends up in a dead end, we give it a penalty. And this is our reward down here. And then we move to a new state and we rinse and repeat until hopefully we actually get through the maze. It's all about maximizing the total reward over time. And so if we iterate this maze many, many times, we get better at it and we'll end up completing the maze in fewer moves. Now, let's move down to here. Policy. So, the agent, that's the person, develops a policy. And all a policy is a strategy for choosing actions. It's like learning the best moves to win the game. So that's policy. And then finally down here, exploration versus exploitation. So a key challenge in reinforcement learning is balancing exploration, that's trying new paths, trying new things out, with exploitation, using known good paths, using the safe way. It's like deciding whether to try a new strategy or stick with what has worked before. Excellent. Reinforcement learning has exciting real world applications. We can think about self driving cars navigating traffic. We can think about robots learning to walk or manipulate objects. If you've ever used AWS Deep Racer, that's an example of reinforcement learning using a car on a track. Also, AI playing complex games like Go or StarCraft. And finally, we've got some reinforcement learning algorithms. Again, I'm not going to cover the detail. You can look these up on the interweb, but here we are. Q learning is one good example. We then have deep Q network, and then finally, policy gradient methods. Remember, reinforcement learning is all about learning through interaction with an environment. It's perfect for tasks that involve sequential decision making where there is uncertainty. And there you have it, gamers. Reinforcement learning demystified. So keep these points in mind, and you'll be very well prepared for any exam questions on this topic. And again, if you have enjoyed this video, you know what to do. You're going to like and subscribe to reinforce all the wonderful learning we've done today. Game on, AI learners. This is Digital Colmer signing off.